What's good, all my statisticians out there? This is Professor Sampson with PS I Love Math with another math banger. Today we are doing statistics. This channel focuses on statistics, developmental math, and college algebra or high school algebra, depending on which one you want. But don't forget to click the subscribe button down here on the left or on the right in pink if you want to be around for another math banger. All right, so today we're doing statistics and we're going to be talking about getting a confidence interval. All right, and then we're going to discuss what type of confidence interval we're going to be getting. So let's jump right into it, and I'm going to share my screen so we can get on to it. Okay, so let's see what we have here. Oh my God, we're talking about confidence interval for population mean. Now in parentheses, I put sigma's unknown. So you will not be getting that information from your instructors, or not from many instructors, definitely not from college instructors. You'll be asked to find out whether sigma is known as sigma or sigma is unknown. Why is that important? Because if sigma is known, we use a z-test. If sigma is unknown, we use a t-test. Remember, on this channel here, we're focusing more on using the charts with the calculator, not just putting things into the calculator. So as we look at this problem, we're given a stem and leaf plot. So you should be able to read the stem and leaf plot using the key at the bottom. 2 equals 22, 23, 23, 28, 29, 29, etc., etc. And up in the left-hand corner, you see that it says C, which is your confidence level, is going to be 95%, which they changed to 0.95. So it doesn't ask anything else other than we're going to find a confidence limit. We're going to find a confidence interval. So let's see what we need to do. The first thing we need to do is we have data. Data means information that we need to put into the calculator. So we have data. So we're going to put this data into our calculator. So let's switch over to our calculator and talk about data. Now I've already put the information into the calculator. All right, so here are the data pieces that as I said before, when we were looking at that problem, here's all the data pieces. You can always pause the video and go back and put those data pieces in so you can follow along with me. I usually put all my pieces in L1, which I did here. So here are all our data points that we have here for L1, all right? So we have our data points in here. All right, what do we need? How do we work? How do we go about finding the information? So let's go back to our page and work through that. So the thing that I like to do is write down my knowns, or write down what I need, or write down the formula that I need so that I can focus exactly on what I'm going to get. So as we said earlier, we're looking for a confidence interval. We're looking for a mean confidence interval, which means your population mean, the letter from your population mean, which is what? Going to be mu, right? Mu. That's going to be the letter in the middle because that is the population mean. So we're trying to find out in between, all right, where's the mean? The mean is going to fall in between these two numbers, okay? So let's see, what formula are we going to use? Now, regardless of who your instructor is or what school you're at, you may have a formula sheet. I just happen to have a formula sheet here that I give to my students, but it doesn't matter. All right, here's a formula sheet here. Confidence interval for mean with the standard deviation unknown. This is specifically telling you what the formula is. Of course, I have the formula memorized, so we're going to go there. Let's see if I have it memorized. The formula is X bar, right, minus T alpha over 2. Again, we explained why we needed alpha T as opposed to Z, S over the square root of N, right? Is less than, now we're talking about the mean, so we need the population mean. That symbol is mu, looks like a U, is less than, of course, the upper end. Okay. So here's your formula. So the good thing about formulas is we know what we need. We know that we need an X bar, all right? We know we need a T alpha over 2. We know we need an S, and we know we need an N. So we need all of these things in order to get our answer. So let's start with the first one, which is X bar. That's going to be pretty easy. So after you've input all your numbers from your stem and leaf plot, you go back to your calculator, and I'm just going to do the basic mode. So I'm going to just go to stat, calculate, and just use one variable statistics. And you see my list is in L1. Please don't have anything in frequency list. And of course, this is the 84 calculator. You could have an 83 do similar things, all right? So I have L1, don't have anything in the frequency list. You click enter, and there is your X bar, 35.0625. So I'm going to write it over here, all right? Now, if you're at another school, you have to figure out what your instructor wants. But as far as I'm concerned, the rounding rules are important. So this is a whole number. So these numbers are whole numbers, 22, etc. These are whole numbers. The rounding rule for mean is one more digit than is listed in the data. Our data has no decimal, one more decimal place than is listed in the data. Our data has no decimal. So what your X bar needs to be for to get credit from me is 35.1. Again, this varies depending on what school you at, who your instructor is, all of those things. So let's move on. We have this T alpha over 2. Well, we need to figure out this. Well, what do we know about alpha? Well, we know that alpha is 1 minus your confidence interval, which you have here, your confidence level, which you have here. So that's going to be 1 minus 0.95, which is going to be 0.05. But since you're looking for both sides, all right, you're going to have 0.05 divided by 2. That's alpha over 2, all right, which is going to be 0.025. So hence you're looking for a T of 0.025. And what is that equal to? Well, what do we need? We need a T chart. Yes, we're using the charts here. So we need a T chart. So let me find us a T chart. All right, so wow, here's a T chart. What do we need for a T chart? Well, for a T chart, we need degrees of freedom. We should know that the degrees of freedom is n minus 1. So in our case, shoot, let's say, oh my God, I don't know how many of these. I don't feel out counting them, 1, 2, 3, 4, 5. But the good thing is that you put them in your calculator, and you can see right here that your n is equal to 16. So your n is equal to 16, which we're going to write here, because we may need that later. We do need that later. So your n is equal to 16, but your degrees of freedom is going to be equal to 15. So you're looking for 15 at 0.025 on your T chart. So let's go back to our T chart. So 15 at 0.025. So here's 0.025 up at the top. And then I'm going to come down here to 15. All right. So there we are. 15 at 0.025 is 2.131. 2.131. So your T alpha over 2 is 2.131. All right. And you also need your standard deviation. As I said before, as far as I'm concerned, we need to round to the appropriate number of decimal places, which is one more decimal than is shown in the data, if there's data, and in this case we have data. So in this case, our standard deviation is going to be 9.9, right? That's our standard deviation, 9.9. And this is the standard deviation of the sample. Please don't put no SX there. There's no such symbol. The symbol is S. That's the sample standard deviation. Okay. All right. So let's pop in all our numbers here. So X bar is 35.1. Now remember, when we put these things in our calculator, right, the calculator is going to use all the decimals. You're just writing this in so that you can get credit for showing work. So you're writing in all the numbers rounded properly. Okay. So now you've shown all the work. So now we can go to the calculator and figure out what these answers are going to be. Right. So we're at the calculator. In order to find out what your answers are going to be, you're going to go to stat, and then you're going to go over to test, and then you're going to do a T interval. That's what you're looking for. You're looking for a T, not a T test. You're looking for a T interval. So that's going to be number 8. So I'm just going to hit number 8. I'm not going to scroll down. Now the question is, are we asking, can we put in stat? We can put in statistics because we know it, but we're going to go over here and go to data. Why? Because we have data in our calculator in L1. So we have data in L1, all right? It was that, that's the data in L1. Don't touch the frequency. And then our confidence level was 0.95, all right? And then we're going to calculate, all right? So we get our numbers here, and we have to round them to the appropriate decimal place to get them right. Remember, that's one more, since it's the mean, is one more data place than is listed in the data. One more decimal place than is listed in the data. So let's go back and write out our final answer so we can finish up this problem. So our answer is 29.8 is less than mu, is less than 40.4. Okay, and this is your answer written properly, showing that you know what letter should go in the middle. That is the mean. Do not write it in the calculator, at least not for my class. Maybe for your instructor it'll be fine, but do not copy it out of the calculator as just 29.8 comma 40.4. That's what the calculator gives you. Okay, so this is it. This is how you find a confidence interval for the population mean when sigma is unknown and you have a stem and leaf plot, right? And you're given decimals. So if you need anything else, feel free to contact me, and definitely please subscribe at the bottom to my channel so that we can get more and more videos. Also like it definitely, and comment if you have any comments. If you want to see other videos, please comment, like, and subscribe. Thank you very much. This is Professor Sampson from PS I Love Math, and definitely you should keep loving math too. Bye.